Hi everyone, thanks for coming today to hear about our talk around running critical regulated workloads in the cloud. I'm Matt Finch, Head of Emerging Technology for the NIB Group, based out of Australia.
Hi, good morning everybody. My name's Phil Rodriguez. I work for AWS. I'm based in Sydney, Australia, and I help our customers there with security, risk, and compliance in the cloud. Really proud to have been a small part of NIB's journey over the last few years and excited to get to talk this morning. Remember, I work for AWS. Matt works for NIB. So just remember, the person with the American accent works for the American company, and the person with the Australian accent works for the Australian company.
All right, let's get into it. So I thought I'd start off by setting a little bit of context about our journey so far. A couple of years ago, we started seriously thinking about transitioning some of our critical workloads and core systems over to our AWS-based cloud platform. We'd been using the platform for a few years already. We were running a lot of our digital and web workloads on top of the cloud. And so we wanted to really understand what was the shift in thinking required to actually running critical systems, and who did we need to talk to, what sort of risks do we need to manage, and how were we going to continue rolling out these workloads on the cloud, and how would our platform need to mature. So when we sat down to design this talk, we really wanted this talk to be the talk that we attended a couple of years ago when we started thinking about this. It's really a talk from the trenches. It will share a lot of learnings and insights we've gathered over the course of the last couple of years, and I hope everyone can take something away from it. Now, when I say critical systems, I'm really talking about those systems that are the crown jewels of your business. They're really systems that if something happened to them, it could lead to an erosion of trust with your customers, irreputable brand damage, or potentially heightened regulatory scrutiny. So with that in mind, really organizations, big and small, should be able to benefit from this talk. Whether you're a startup or a large enterprise, many organizations today have core systems that are at the heart of the business and really help that business operate. So what we'll do is we'll set a little bit of context and talk about our journey to date and our regulatory landscape. We'll then jump into a deep dive, as it is a level 200 talk, so we'll have a few architectural diagrams that we'll walk through and talk about how our platform evolved, and then we'll wrap up with a few key insights. So let's get into it. So at NIB, as I mentioned, we're based out of Australia. We're headquartered in Newcastle, Australia, which is a couple of hours from Sydney. And we really have a vision for people all around the world enjoying better health. This starts with our core value proposition that's centered around health insurance and our health insurance products. And really, we're focused on protecting our members against things like the financial risk of disease, sickness, and injury. More and more over the last 5 or so years as well, we've been focused on a number of business acquisitions to grow our footprint globally. And so we've been acquiring companies in the New Zealand market, expanding out into the Asian markets, and also establishing a presence in Europe. And so we really want to make sure that we're providing access to world-class healthcare wherever our members need it, anywhere in the world. And lastly, and I guess most recently, we've been thinking a lot about how can we be more of a health partner to our members? How can we help them as they're going through their health journey, and also help them better prevent, manage, and treat their illnesses? So I also want to touch on our technology strategy over the last 5 years. We've been really focused on laying the technical foundations to support this business strategy and support where the business is going. For us, it really starts with having the right platforms in place, the right cloud and data platforms that are secure, elastic, scalable, and resilient, and can really handle whatever the business wants to throw at it. Building on top of these platforms, we've been establishing our modern digital experience to better service our customers. And so we have a lot of web and mobile apps running on top of the cloud platform today, and we're building out a really great API layer that underpins this. And then I guess most relevant for our talk here today, we've been thinking a lot about what it means to build a next generation core system for our business. Something that's modular, cloud first, really capability driven, and has best of breed components like a CRM. So I also wanted to drill a little deeper into our cloud vision and our cloud strategy. About 4 years ago, we sat down in a room at NIB and we started thinking about what was our strategy going to look like for our infrastructure and data centers for the next years to come. And so as we were in the room, we were talking about what was the world we were living in at the time, what we termed our old world, and what was the world we were trying to move to. And we effectively came up with this infographic up here. Now, I certainly didn't draw that. I'm not that artistically gifted, but we had one of our design leads sitting in our room with us, and we were talking about the fact that in the old world, we were really focused on maintaining boxes and maintaining our infrastructure and data center, and really putting a lot of effort into that. We'd been building out our data center presence, particularly through our business acquisitions. We went from 2 data centers up to 7, and so it was really quite a lot of workloads that we had to continue maintaining. So what we wanted to move to was a cloud-first strategy. And this cloud-first strategy, we wanted to use it to drive competitive advantage for our business. We wanted to be really enabling our business, and we wanted to establish something that would drive the ability to be agile, innovate, and experiment. And so you can see our 6 key pillars up there that our business case was centered around. The first couple, as I mentioned, were really about establishing a platform that allowed us to experiment and innovate. On top of that, we were also thinking a lot about how we could build out a platform that was scalable and secure at the same time. So we wanted to increase our security and risk posture, as well as increasing our resiliency. As I mentioned, we'd acquired a number of data centers, and so we were putting a lot of effort into that, and we weren't really focused on what the business was trying to achieve. And so we wanted to build out an environment that would allow the business to scale things up and down on demand as they wanted to, and also try different things out. At the same time, we also wanted to reduce our operating costs. So we knew that having mixed infrastructure and mixed data centers was fairly inefficient, and we thought at the time that the cloud could help us get there and could make things run a lot more efficiently from a cost perspective. And the last one that was really important for our strategy was we wanted to establish a common group platform. We really wanted that platform to be something that all of our delivery teams right around the globe could continue to leverage, whether they were in New Zealand or Australia or into the Asian markets. We wanted everyone working to a common set of principles and patterns, and we'll dig into that more soon. So off the back of putting together this business case and really, I guess, defining our principles, we moved into a proof of concept late in 2015. And that was really centered around trying to prove out the principles that you saw on the previous slide. A lot of this might seem like commonplace today, this idea of self-healing systems or being more secure through the cloud, not less secure. But for us, we really had to prove it to ourselves, as well as our executives and our board, that these things could actually come to life, and it wasn't just some ideological principles that we'd put on paper. And so the proof of concept went really well. We learned a lot out of that, and we took those results into a business case strategy that we took forward to our board. And again, late in 2015, we sat down with our board and we had a really robust discussion about why we wanted to move to cloud, what were the business benefits, what were the risks of moving to the cloud, and how were we going to mitigate those risks, and what would the journey look like, and what would the investment be that was required. And so that was a really positive discussion, and off the back of that, we obtained board sign-off and moved into our first production workload early in 2016. From there, we steadily ramped up our workloads and transitioned them over to our cloud platform. So we had about 100 apps live and running around the middle of 2017, and then late in 2018, we hit about the 200 mark. And I'd say today we're getting close to 300. So this steadily continues to ramp up, and it's really a combination of migrated applications out of our data centers, as well as new cloud-native apps that we're continuing to build. But as I touched on, the business case wasn't purely around migrating apps out of our data centers. One of the first major milestones was achieving PCI compliance for our cloud platform as well. And that really goes to the idea of being able to increase our security posture. It was quite a big milestone for us, and it was something that we wanted to achieve for a long time in our own data centers. And it was great that the cloud platform enabled us to get there. Going along the same lines as achieving our business case goals, late in 2017, we launched our flagship innovation piece, which was Nibby, our chatbot. Nibby's built on top of Amazon Lex, and again was enabled through our cloud platform, and it really goes to the heart of being able to experiment and innovate and try new things out. It's not something we'd been able to achieve in our old environment. So it was early 2018 that we started to think then about our core systems and how we would transition them over. We'd moved probably 90 to 95% of our lower risk digital workloads to our cloud platform. And so we started to really turn our minds to that and do a lot of thinking around how we would approach this. And that's mainly what this talk's about today. But work didn't stop there. We completed another business acquisition in 2019. And that business acquisition drove the need for establishing a contact center presence at a few different places around the globe. And so we leveraged our platform again through Amazon Connect and Amazon Workspaces to establish that global contact center footprint. And that was really successful. And so then just a couple of months ago, we moved our first regulated critical workload over to the cloud, which was really a major milestone in our cloud journey for us, and was really a historic achievement right around Australia. And Phil will touch a little more on why that's possible. So before I hand over to Phil to set the regulatory landscape for Australia, I just wanted to touch on our risk culture at NIB a little bit. A really big part of transitioning critical workloads over to the cloud is your ability to manage the risk around it. And a lot of risk management is being able to explain how you're managing the risk and what controls you're putting in place. And so at NIB, we really see risk as an enabler. It's something that we bake into everything we do, and it's not something that slows us down. And we have an internal saying, the bigger the brakes, the faster the car. And what that really means for us is that if we can bake risk and the controls into all of our delivery processes and the way we release applications and deliver new innovations to the market, then we can do it really, really fast. But knowing that we've got that safety net behind us, so if we do need to fall back on it, we've got the right controls in place. So now I'm going to hand over to Phil so he can give you a little bit of background on the Australian regulatory landscape and why transitioning a critical system over was such a big deal for us.
Thanks, Matt. The Australian Prudential Regulation Authority is one of two major financial services regulators in Australia. Historically, Australian financial services companies were regulated by a really complex mix of both regulatory agencies and legislation at the state and the federal level. In the late 90s, Australia consolidated this into two major financial services regulators that operate nationally. The first looks at market stability, and we call them ASIC. The second one focuses on safety and security. They oversee deposit-taking banks, credit unions, insurers like NIB, and superannuation, or what you might call retirement funds. And this is APRA. APRA has a really broad set of powers. They're able to enact legislation and other requirements. They supervise entities to make sure they're aligning to those requirements, and they're able to issue penalties as they see fit, either in the form of fines or other additional regulation. Now, this broad set of powers is common with other regulators around the world, but in Australia, it's highly centralized. APRA is the key regulator that has these powers over the financial services entities in Australia. NIB is a global business, as Matt just described, so they need to worry about the regulation both in Australia, their primary market, and in the other jurisdictions that they operate in globally. For example, they need to align to GDPR with their European operations. Also, they've chosen to follow a number of global standards. Matt already mentioned PCI DSS as one of those. All of these standards overlap and create sort of a ceiling of regulatory obligations that NIB has to follow. So what they've decided to do is internally set the bar very high on their risk culture to make sure that their internal corporate policies and the controls that they're implementing based on those policies meet their highest obligations globally. Another way to put it is GDPR, even though it's just European, will influence the policies and controls that they take around the world, including in Australia. And these external regulatory requirements change all the time. They're constantly evolving. NIB's internal technology capabilities are constantly evolving, and they're acquiring new businesses as well. So this creates a really complex set of requirements that they have to follow that are constantly updating their internal requirements. What they've learned is it's not as important to do it correct once. They need to create a process where they can continually baseline themselves to these changing external requirements and continually validating the controls that they choose to implement internally. This can be a lot for any one entity to deal with, right? Complex changing external regulation, complex changing internal requirements, acquisitions, etc. So what NIB has chosen to do is align themselves to a few key external influences to set their principles throughout this journey. One of those is obviously from the regulator themselves. So in Australia, APRA published a paper shown here called their Cloud Information Paper in late 2018. And this was really important in the Australian market because it set the guidance by which financial services entities could migrate core systems into the cloud. It sets out a lot of things in the paper, including what they call observed weaknesses. These are things that the regulator has observed through their supervision of other entities and noticed that entities were getting wrong a lot. So this is sort of a list of bad practices, things not to do. NIB decided quite clearly in the beginning that they would not be doing anything that was observed to be a weakness. Very simple strategy, but it worked very well. And they highlighted both the technology and the process associated with these observed weaknesses to make sure they informed their board and their regulator that they understood these and had controlled against them. In this info paper, there's two key terms defined, which I just want to go over briefly. The first is a system of record. This is a really common term in Australia, and it just means the definitive source of a financial transaction. Think about something like a general ledger in a bank or like a claims and policy system in an insurer. These systems of record are what APRA calls extreme inherent risk arrangements. That means they have the potential, if disrupted, to cause a massive impact to the bank or any financial services entity, for example, maybe not to be able to meet the obligations of their customers. APRA obviously doesn't want that to happen, so they've classified some systems in this highest risk category. This info paper was really important because they also published the rules by which entities in Australia could migrate extreme inherent risk workloads to the cloud. And these are the rules that NIB followed. The second external reference that NIB has chosen to follow is AWS's well-architected framework. If the APRA paper contained a list of what they shouldn't do, then the well-architected framework contained a list of what NIB would be doing. I hope everybody here is familiar with it. It covers the 5 key principles that AWS uses to recommend customers build any types of cloud workloads. One of those pillars is security, and I'll dive into that one a little bit deeper later. And another key pillar in our well-architected framework from APRA's perspective was our reliability pillar. Why? Again, the prudential regulator, whose primary purpose is safety and security, wants to focus to make sure that entities are able to meet the needs of fulfill their obligations to their customers, both today and tomorrow. So reliability, resiliency, recovery, and all the things that Matt is going to dive into was very, very important to the regulator. The AWS well-architected framework gave NIB both general technology principles that they could align to, and also a specific benchmark with which to use technology tooling to measure their progress over time. And we're going to show some examples of that later. Regulator engagement is not like technology project management. What NIB learned is that it took a constant cycle of iterations for engagements with multiple stakeholders, both inside their business and outside. They had to engage many times with the regulator. They had to update their board and senior execs. They had to engage with internal lines of business, and they had to keep other technology teams updated. This process of iteration helped them because it drove maturity into that solution over time, and because it raised the comfort level of these stakeholders, but these constant iterations take time. So the key takeaway here is when you're moving these types of systems, plan ahead and make sure you're giving yourself sufficient time to get your regulator comfortable with your approach. Okay, that's the end of our kind of general scene setting and a little bit of NIB's journey over time. What we want to do now is break into a set of deep dives and get a little bit deeper. NIB aligned themselves to these 10 key areas throughout the course of both the technology project and their regulatory submission. We're not going to have time to go into all 10 of these today, so we're going to break out these 5 specific areas in a set of chapters over the next part of the talk to get a little closer. Why these 5? These are the areas that we think other organizations could benefit from using the same patterns that NIB has established. All right, Matt, back over to you.
Thanks, Phil. So one of the first areas that we really needed to spend a bit of time understanding was our operating model. It's really a non-technical area, but it was really important that we understood it, understood the changes that were required, and were able to communicate it both internally and externally to bodies such as our regulator. So to get started thinking about our operating model, we really started with the AWS Shared Responsibility Model framework. If you haven't seen it, it's a great framework. I really recommend that you check it out. Effectively, what they spell out in there is what are the areas and the things that AWS will be responsible for and that they'll have to continue owning, and what are the areas that us as the customer or you as the customer will need to be responsible for and that you'll need to own. And so for us, effectively, we distilled that down into the orange box you see at the bottom there and said, okay, effectively from AWS at that point in time, we were getting managed data centers and managed infrastructure, and we would need to move that out of our operating model. But from our perspective, we really had 3 main areas in our technology operating model that needed to continue to evolve and change over time. The first one was our security risk and governance approach. We had to put a big focus on cloud risk and cloud security, how we would implement controls, how we would manage things like data flowing between the cloud services, looking at the services we'd adopt and how we would threat model against them, and making sure we were conducting the proper due diligences of using those services. The other area that was really important for us was our ability to support the cloud platform, and that matured itself through our DevOps and cloud services practice. So having the right cloud support and governance options in place, and being able to look at traditional things such as continuity of service or DR testing, as well as change management, and understanding what those look like in a cloud-native world. The third area that was really important to us was our architecture and strategy function, and making sure that we set out this great strategy and great business case that you saw earlier, making sure that our teams continued to adhere to those principles and operated in that environment on that common group platform, making sure we were aligned to the business case and making sure we were conducting things like architecture reviews as new applications were released onto our platform. The other area we spent a bit of time thinking about was things from a functional perspective or a technology perspective. What were the areas that we were going to need to mature and continue building capability in? And so again, we used the shared responsibility model to drive our thinking, and we broke it down a little further and said, okay, from AWS, we're going to get data centers, but built on top of those data centers, we'll get compute, storage, and network. But one of our first responsibilities was building a defense in-depth virtual network right across that environment. And this is effectively our VPC architecture, as well as our account structures and how many accounts we'll have, how they'll be set up, and how we'll manage identity and privilege access management into the environment. The other two key pillars that really influenced our thinking was our security and risk controls that we wanted to bake in. And as I touched on earlier, we had a goal of obtaining full PCI compliance, but we also wanted to be ISO aligned. And we had some of our own principles, such as encryption completely across the stack, at rest and in transit, all the way down to the instances. And we wanted to bake things in like automated security hardening and vulnerability management. The other key pillar for us was around continuous delivery, but not just that, as well as continuous assurance. And so making sure that as our developers and delivery teams were releasing applications or releasing change into the environment, they could do it in a speedy manner, but do it with a lot of confidence behind them. And so this really came to life through principles such as continuous incremental code delivery, baking in vulnerability scanning in our build pipelines, and making sure that we had things like automated DI testing underway so the developers could move with a sense of confidence. What this influenced for us was a whole bunch of areas that we would need to take responsibility for as we continue to build out our cloud environment. You can see up here a lot of these areas we were already thinking about traditionally, and so we had to continue to put extra focus on those areas. Traditional things like internal firewalls and external firewalls, we had to think about how that would mature and how we would build a capability around that. Operating systems, the patching of those operating systems, the hardening, these are all areas that we can now put a lot more focus on because that bottom layer was taken away from us. So how this evolved and came to life for us is what we call internally our Red Queen platform. The Red Queen platform in NIB is really a series of cloud services that we've tied together through automation. And so the platform has a big focus on automation. We give our developers standard templates and frameworks. So as they're delivering applications into our environment, they can pick up a template and say, okay, I need to deploy this application into this particular zone. I'm going to get a multi-availability zone design baked in. They're going to get automated patching and hardening of their images. And they'll get simple things like secrets management as well as application routers. The other thing that's really important about this platform is the introduction of these different cloud services. Many of these vendors are here today in the reInvent Expo Hall, so I definitely encourage you to go and have a chat with them. But they're a big part of making sure that we start filling those gaps that you saw on the previous slide there and maturing the capability in a cloud-native way. Now you might think this is an added level of complexity, having this many different vendors in the mix, but it's proven to be a fairly positive risk management technique for us. And as we describe and explain our platform to our internal and external stakeholders, we can use examples such as Okta. It really helps us reduce our blast radius as Okta provides single sign-on into our environment. And if something was to happen to other parts of our environment, we should be able to continue signing in and servicing our members. So as I mentioned, we put a big focus on automation and thinking a lot about infrastructure as code and how we deploy configuration standards into the environment. But as we got to explaining why we were making the decisions around the configuration standards, we had to really take a step back and think about what were the things that were influencing and driving those standards and how could we best communicate that. And so when we took a step back, we realized that there were a number of policies and standards that we were inherently baking into our configuration controls. And so we basically adopted an approach internally called policies as code or standards as code. And what we've done is we've taken our policies and standards, some of them I touched on earlier, such as PCI compliance, and we've turned those into codified patterns. Those patterns really describe how our environment needs to be configured. They're completely version controlled as code, so we get full auditability right across the stack, and we can conduct things like change management and understand what changes are being made to the policies upstream and how they affect the patterns that get rolled out to our workloads. So drilling a little deeper on our patterns, we really set a high baseline, and it's an important point I want to touch on. When we started out and we were running a number of lower risk workloads, there were a number of things that we built in from day one because we knew we were going to be moving into more higher risk workloads. Things like encryption at rest and in transit and multi-availability zone designs. These things, while they're not completely necessary for applications that are lower risk, we wanted to make sure that we set that baseline high and we knew how to operate a robust environment. And they're a really key part of our business case and our strategy that I touched on earlier in terms of increasing security and risk posture, as well as increasing our resiliency. But as we started moving extreme risk workloads over in the systems of record that Phil touched on earlier, we had to continue evolving and maturing these patterns as well. And so 2 key examples that I've called out up there is for our extreme risk workloads, we restricted the types of cloud services we'd adopt and run in those environments. And this was really so we could conduct a more thorough due diligence around those services and really understand how they function and operate. The second key one was making sure we had a contingency plan in place and making sure that we also were able to test that plan continuously, and we knew exactly how it would work and what we would do in those scenarios of failure. And I'll drill into those a little more soon as well. So as I mentioned, we're able to take those patterns then and then roll them out in an automated fashion to all of our workloads. And it's been a really scalable approach. Whether we have 1 workload as we did at the beginning, 200 workloads or 2,000 workloads, it really doesn't matter. It's the same controls and standards that are getting applied. And then as the policies and standards themselves are evolving upstream, we can make the changes in one place and then automatically roll them out to all of our workloads. From there, we effectively feed that up into our governance process. So we meet monthly to sit down, look at the RegQueen platform and really understand how the applications are evolving, how the external landscape is changing, and how those compliance requirements need to get fed back into our platform. And so governance is really a big key part of our platform internally. As Phil touched on earlier, the AWS well-architected framework is a great framework for thinking about how you build out your environment and architect it. For us, we also found it to be a really great framework for thinking about how you govern your environment. And so we use a great tool from a company named Cloud Conformity. They've also got a booth here in the expo hall. And effectively through Cloud Conformity, we get a snapshot across our 5 AWS well-architected pillars. And as we meet monthly in our governance forums, we're able to look across the pillars. In this example, we could take reliability. We could drill down into it and we'll get a series of best practices and areas of opportunity for us to continue shifting the dial there. Now these dials move up and down in real time, and that's purely because the external landscape continues to evolve in terms of the controls that you should implement and the best practices that you should put in place. So this has been a really important function for us and also a really important thing for us to demonstrate to our regulators and other external bodies that we understand how we can govern and manage our environment. So now I'll hand over to Phil so he can take you on a deep dive through our security practices.
Thanks, Matt. All right, let's dive a little deeper into my favorite pillar, security. APRA has an observed weakness in that cloud info paper I talked about around its observation that regulated entities didn't have sufficient ability to protect, detect, and respond to security incidents. What NIB did was decided to base the foundation of their security program on the NIST Cybersecurity Framework, or CSF, which is a really common and effective pattern that we see in mature customers. This gave NIB an ability to decide for each one of these phases what types of services they were going to be using from their different service providers, including AWS, and which third-party controls and third-party toolings they might need in order to complement those. So let's take a quick look at these phases and some of the decisions that they made. The identify stage is all about understanding assets and where they might be inside of your environment. Here, NIB used a combination of both AWS config, which is our tool to look at the configuration status of different resources around your AWS environment, in addition to AWS Systems Manager, which can be used to interrogate assets, specifically like operating systems that you might choose to run inside of the cloud. The protect phase is always super important in security. Here, NIB aligned to our well-architected framework again and centered it around a number of principles. For example, identity is always a primary security control in the cloud, and they chose to use AWS IAM. For secure networking, they used things like Amazon VPC. In order to implement a lot of that encryption, they used Amazon Key Management Service, or AWS KMS. I want to highlight 2 things in the detection phase. The first is they chose to use Amazon GuardDuty, which is our absolutely awesome cloud-focused intrusion detection platform, which sends an alert to customers when we detect suspicious or malicious activity inside of their cloud environment. NIB forward these alerts and other logs and telemetry from their environment into their security incident management system. And this SIM is monitored constantly, 24/7 by 365, by their external security service provider of choice. When that external security service has a human that triages those alerts, they can confirm if these alerts are just noise, if they're actually security related. And if it is security related, they set off a series of human interactions and automated interactions in order to update NIB. For example, a technology integration into their paging system, so that if the global service provider notices something that's off hours for NIB's main headquarters, they can page an on-call engineer. NIB chose something really interesting here, which is to insert an additional phase into the NIST CSF. This is actually in line with AWS's recent incident response white paper. So the investigation phase allows them to take the output of their detection and response and turn that into a way to perform forensics should they need to. The primary mechanism for this is by storing different forms of logs and artifacts in an immutable or unchangeable log bunker. For example, by taking CloudTrail and CloudWatch out of the environment and keeping it someplace safe that you can't change. This gives them the ability to have a history of activity should it be maliciously or accidentally deleted. And it also can be used as a source of truth should they need to engage an external forensics investigator for a more formal response to an incident. The final stage of the CSF is recover. And remember, there's both non-technology recovery, for example, updating of processes and documentation and thus documentation platforms, in addition to technology recovery, which is understanding the root cause of the incident, correcting it, and remember, going back to correct that infrastructure as code definition, which is where the original flaw actually lives. So they need both documentation and code repositories in order to recover properly. A best practice for this whole thing is to do what NIB did and run a series of game days across the entire lifecycle. NIB worked with AWS and a few of their other partners and gave their teams operational experience by running through scenarios across this entire lifecycle in order to get them more experienced. It helped to test and validate a lot of their tools and make different choices aligned with each of these phases if for some reason the technology integration wasn't driving the outcomes that they wanted. An important thing for the regulatory submission is the running of these game days created artifacts like process improvements or the output of logging related to the actual exercises, and they use these outputs as artifacts in their regulatory submission to show APRA the level of maturity that they developed around these processes. One great example of one of these processes addresses another concern that the regulator had around entities not having the ability to do privileged access management or to properly escalate access and administrative credentials inside of their environment. What NIB decided to do was create a series of technology and process in order to make sure that an administrator could not modify an instance in production, but could get temporary emergency access if they needed to for a diagnostic reason. For example, maybe there's an operational issue in a single instance running as part of a multi-instance auto-scaling group that they need to access to diagnose. Or maybe there's a temporary log that's created because of an operational fault that they need to retrieve from that running environment in order to analyze it to update their infrastructure as code. So there are reasons when temporary but highly monitored access might be needed. Let's take a look at that as an example. So imagine we have an NIB administrator and they have a need for this temporary administrative emergency access. What they do is they submit a ticket to a structured system saying who they are, why they need this access, when they need it to start, and how long they need it to last. This is reviewed, and when it's approved, a Lambda function kicks off, which does a number of things. One of the most important things it does is it creates a unique encrypted credential that's associated with that one-time access and pushes it via systems manager to the instance that's going to be accessed. Another thing that it does is it creates a security group that allows this very specific access. Now the NIB admin has a network path and credentials in order to access that production instance. The entire time in the background, a timer is running. When this timer expires, a few things happen. That security group is deleted, which removes the network access. Those unique credentials are expired, which removes the authentication access. And that production instance that was touched is terminated. And another instance is generated from the code definition. Because remember, they're not trying to change their production instance. They just need to retrieve diagnostic information to make a change to the infrastructure as code definition that started the instance. This entire process is monitored, it's logged, and it's audited. And all of the logs from CloudTrail, CloudWatch, et cetera, generated from this are sent to that secure log bunker again. This is a really effective pattern, and we recommend other organizations adopt the same. All right, let's keep looking at the other pillars, so back to Matt.
So just as important as security is to us, and it was a big part of our business case earlier, the reliability and the resiliency of our environment is also paramount. And so I'm going to take you through some of our approaches. I'll start with availability. Effectively, we follow a fairly standard three-tier availability pattern. At the topmost tier, we run our public-facing services. Typically, these are things such as the elastic load balancers. And built into these services, we have pre-baked health checks and auto-scaling configuration, so that if something was to happen, say a performance spike occurred or an instance was marked unhealthy behind the load balancers, we'd be able to respond to that in an automated fashion and replace that instance with a healthy or a clean one, or scale out as required. At that middle tier is really where we're running most of our applications and our instances. And we put a big focus on making sure that these instances themselves are completely immutable, and we try to drive all of the state out of this environment to the bottommost tier. Now, the reason for this is that we want to be able to self-heal. If there is a problem that occurs at that middle layer, we want to be able to replace it with a completely fresh instance with no human intervention required. Now at the bottommost layer, as I mentioned, this is where we keep our data, buried deep in the networking stack. And it's really focused on making sure that we're able to fail over between the availability zones. For example, a database might have a primary secondary configuration. Now this whole architecture is centered around one main goal, and that's to withstand the loss of a complete availability zone. And so every decision we've made along the way has been centered around achieving that goal and looking at the different scenarios when that might occur. So before I touch on how we test that, I also wanted to point out that it's really important to understand the people and process that are required around availability incidents and how you would manage that. This was a really important part for us to explain both to our auditors and our regulators and walk them through what this life cycle looks like. So very similar to the security life cycle that Phil took you through earlier, I'll step through it. To get started with, we have our monitor phase. And as I mentioned, we have pre-baked templates and frameworks, so as a developer comes along and wants to deploy an application, they can adopt these pre-baked health checks and patterns that are available. From there, they're also able to extend that to cater for any additional logs and events that they want to monitor that are a key part of their application. The next phase for us is detection, and we've really put a huge focus on making sure that detection is completely automatic. We don't want to have our developers or our DevOps teams sitting there poring over logs and events that are being emitted out of our detection systems. And so we want to make sure everything is completely automated at this stage. The next step is where we've taken the automation a step further. And the first level of response, or the first actions we take, we also put a focus on making sure they're automated. And as I mentioned, these typically come to life through things such as auto-scaling events or self-healing events. So an instance will get replaced as a first layer of response to see if that resolves the availability problem. But we can't automate all types of availability issues. So this is where we follow a ChatOps style process where the events and the alerts go into our Slack channels. So our developers and our DevOps staff can look at the events, understand what's happening and rally around resolving it. And if it's after hours, we're able to page our on-call engineer via PagerDuty to have them jump in and resolve the availability issue. The next step for us is really tracking the incidents that are occurring and understanding the availability issues. And so teams, as I mentioned, are distributed right around the globe now. They can sit down and they can work with their stakeholders and the relevant business stakeholders that use their applications, and they can track the incidents and understand what's happened, conduct post-incident reviews, and spend time making sure that their application handles that failure in the future better. But from here, we take it a step further and roll it up into our governance forum right across the group. And what we do during this governance forum is we look for trends, and particular availability trends. If we're seeing the same availability issues occurring at different points around the globe, we can then look at our Red Queen platform and think about how are we able to build in the protections that are required around those availability incidents and continue maturing the platform so everybody benefits. So as I touched on earlier, it's really important that we test this idea of withstanding the loss of an availability zone. And so to do this, we've taken a page out of Netflix book and we follow a chaos engineering practice. We've developed a simple tool internally we call Gorilla. What Gorilla does is it blanks out an entire availability zone for us. It's something that we can run on demand. We really run this a number of times in our non-production environments to understand how our applications respond to failure and look at the different scenarios where we need to bake in the controls required to those failures. Now in production, we also run it on a semi-scheduled basis, more akin to a traditional DR test. So again, we can understand how the production applications will respond in that scenario. Losing an availability zone is quite rare, so it's been really important that we can run this test for ourselves and know exactly how our applications will respond. And it really gives our developers a sense of confidence as they're running applications in the real production environment. Now, back in 2016, in the Sydney region in Australia, AWS did encounter a full availability zone failure. And we went into that with a high level of confidence. And fortunately, none of our engineers needed to be paged that night, so we survived and fared that fairly well. The next part of resiliency for us is really centered around recovery and how we recover from issues, in particular data issues or other types of recovery scenarios. So as most things in our environment, we've put a heavy focus on automation and making sure that we've codified our backup policies. We took a hard look at what were the different types of backups that we needed to put in place, and we tried to simplify this across a range of different policies. And typically these will be aligned to our business continuity requirements or our business standards around how the data needs to be stored for particular applications and how long we need to keep that data for. So we might have a data store where the data is transient and it only needs to exist for 7 days, so the policy will enforce that automatically. Or we may have applications where the data needs to be kept for 7 years, and again, the policy will keep that in check. We also bake in particular controls into these policies. And so things like MFA delete and then S3 versions will be made available to all of our backup storage locations. These run across different types of storage environments as well. So these could be S3 buckets or RDS instances. And we've put a big focus on making sure they're application specific and point in time. And again, the main goal here is to make it easy for our delivery teams to move quickly and understand how they need to bake these patterns in. So the patterns themselves get pushed automatically out to all of our workloads. And again, this is a big part of having that continual assurance to make sure that as the policies are changing upstream, they get built into our codified backup patterns and we're able to push them out in an automated fashion to all of our workloads. Now, I want to step you through a very simple view of what recovery looks like in our environment. But before I do that, it was really important, again, that we took a step back and understood the plausible disruption scenarios that could occur in our environment and how our recovery approach would help us address those disruption scenarios. The two key ones that I really wanted to call out really goes to the heart of compromised credentials. Now, that could happen through collusion between two internal parties that have come together to get access to root keys or admin keys. But it could also happen if there's just been a breach and some sort of credential has been compromised. This is the most serious risk that we had to put controls in place for. It's really the more likely scenario that could cause a massive disruption to your environment. And so we really had to think a lot about how we would protect against that. But there are also a number of smaller disruption risks. We could have things such as software errors, we could have a failed change that goes into the environment, or we could simply have a replication issue that occurs between a data store. So I'll step you through what that looks like. Effectively, our application server and database server are backed up to a series of S3 buckets, as I touched on earlier. From here, we've implemented our first line of defense. We have a special AWS account in our environment we call our AWS bunker account. And from here, we've got a completely separate set of encrypted credentials, a separate way of accessing the environment, so a separate process that people need to go through, and a completely separate set of IAM credentials as well. This is really designed to help protect against that idea of credentials being compromised. If something were to happen in our main environment and the credentials were compromised and the entire account was blown away, we should be able to stand things back up from code in our bunker account and restore the production environment. From there, in this example, we could lose a database server. We can then extract the backups out of the backups bucket, stand up a recovered database in an automated fashion, and then redeploy our application as code and repoint it to the recovered database. And this is an entirely automated process for us and something we can continually test and get assurance around. Now, as I touched on, those were some of the more likely scenarios and the things that we needed to put controls around. But when we were moving a system of record over in our most critical system, we had to also think about the extremely unlikely scenarios. And there was one that kept coming up to us time and time again. And that was, what happens if our first layer of defense also fails and we lose all of our AWS accounts, including our bunker account? And so effectively, to put a control around this, we implemented what we refer to as our alternate hosting arrangement. And so quite simply, this is a second layer of defense for these highly critical systems. We replicate the backups again to a storage mirror. And from there, we can lose all of the AWS accounts in our environment, and we can stand up the recovery from that storage mirror to a recovery server. Now, I must stress, this is a really unlikely scenario. The much more likely scenarios are some sort of compromised credentials or something that could affect one or more of your AWS accounts. But because we were moving this workload over, that's a highly sensitive, and as I mentioned right at the start, this was a crown jewels workload for our organization. We had to put a control in place, and we had to be able to have the confidence, both with ourselves as well as our executives, our board and our regulators, that we knew what we would do in this scenario. And so that leads me into the last point, which is making sure that you've got a contingency plan in place. And so for us, we had to do risk tiering. We had to look at the applications that were low and medium risk. We were happy for them to be running across multiple availability zones. But for our most material services, we had to have a contingency plan in place. And that came to life through this alternate hosting arrangement. We also had to make sure that the workloads we were provisioning, and in particular our system of record workloads, had portability in mind as we were designing these workloads. So we could move them around, or we could move the data around in a simple fashion so we could test it continuously. And the last one was making sure we had the right commercial exit clauses in place. It's not always an unplanned exit from the cloud, so we had to make sure that we had enough time if there was some sort of commercial disagreement that we could move away. And that's something we worked with our cloud service provider, AWS, on understanding. So now I want to leave you with a few key insights and some really, summarize some of the takeaways from our journey to date. The first one is, and I guess this is a question I get the most when we do this type of talk, is what's the silver bullet? How do we move a system of record over? And for us, it was really a context-specific journey, and I think it'll be the same for you. There's really a lot of thinking that you need to do around your environment, understand your situational and have more situational awareness, and think about the context that you're operating in. For us, we were an Australian regulated insurer, and so we had to go through a series of steps to make sure our regulator was comfortable. But for you, it might be something different. So really understand that context. And I guess to Phil's point earlier, it really is a series of iterations. So be ready for ongoing dialogue internally and externally. Cloud journeys can be long. For us, it's been 4 years and we've still got more time to go. And so we had to make sure that our executives and our internal senior management were still on board with the journey. We had to make sure that our developers understood why we were moving down this path and the controls that we were putting in place. And we had to make sure our external parties, such as auditors and regulators, understood what we were doing and why we were doing it. So it really is a big communication and phase, and there was a lot of ongoing dialogue required. We also used a number of frameworks, as Phil and myself have touched on throughout this talk, and so I wouldn't be afraid of using multiple frameworks. For us, we found it to be really key to look at those frameworks, apply them in different scenarios, and not get too fixed to any one particular framework. Another big part of this is using multiple partners. So for our technology implementation, we had a great partner in CMD Solutions, who's now one of AWS's premier partners in Australia. We also had a non-technical partner in Capital Consult who helped us understand the risks and how we would manage those risks as we engaged with our regulator. The next point is remembering that the cloud journey is not just a technical journey. It's really a journey of both non-technical and technical migrations. So thinking about your operating models I touched on earlier, thinking about engaging with your internal teams such as enterprise risk, procurement, strategy, working through and making sure they're understanding why you're going on this journey and what you're doing, and hearing their questions and having that conversation with them. And lastly, I'll say remember the people. It's really a cultural journey. It's really a journey that you may need to have new skills around. You may need to bring on new roles. We run a number of training sessions with AWS and our partners, as Phil touched on, game days. So bringing the people along for the journey, maturing and building out the capability is a really, really important part of this.
To close, I just wanted to summarize a couple things. AWS has established effective patterns for people to run secure and reliable workloads in the cloud. Our customers, like NIB, have taken these patterns and are starting to migrate their most secure, most resilient, highly regulated workloads to the cloud. It's a really important moment in the industry for everybody to start doing this. Our takeaway today is really clear. You've heard the talk, you've seen the principles and the patterns that were established, and you've seen an example of how to do this right. Go back in your own organization, identify your most critical workloads, and start your planning now for how you're going to migrate those to the cloud. People like NIB have done this, other organizations have done this, and you can start to do this now as well. So, in summary, get started now. The start to any one of these journeys is really about education. That's something that I'm finding repeatedly in engaging with customers over the last 2 years. Remember, get your cloud people trained on security and get your security people trained on cloud. And if you can get them both in the same room at the same time, even better. Engage with our training and certification program. I'd like to call out especially our security engineering on AWS class, and also start your journey towards our AWS security certification. Thank you so much to the hundreds of people that came out on this unusually rainy morning here at the world famous Bellagio Hotel and Casino. Thank you very much for your time. Thanks to the thousands of people that are going to be watching this talk online later. We really appreciate your time. And if I can ask one more thing, your feedback is really important to us, especially with you in this audience here this morning. So if you could take a moment now, take out that conference app and give us a rating for your feedback, we'd really appreciate it. We do have about 10 more minutes for questions. So if you want to come down to the front and ask us any questions or use the mic, we're really happy to stay around and keep talking about this topic. Thanks for your time and enjoy the rest of the conference.
Thanks, everyone. Really appreciate it.